Billy Smith is a software engineer at Northrop Grumman. During his 7 years with the company, he has been heavily involved with his site's adoption of model-driven development and has taken multiple software designs to maturity using the MDE approach. He has a BS in computer engineering from the University of Oklahoma. Kevin Nguyen, also from Northrop Grumman, is a software engineer. He is a subject matter expert for model-driven development. He has been providing his teammates guidance to mature software designs with the MDE approach. He also has served as a MDE consultant for the Northrop site. He's a strong believer in the object-oriented design and software architecture. He has an MS in Systems Engineering and MS in Computer Engineering, both from Florida Institute of Technology, and a BS in Computer Science from University of Iowa. Please welcome Billy Smith and Kevin Nguyen.
Yeah, so today, hopefully, I just want to come here to share our experience with you guys about how we do MDE, model-driven engineering at Northrop Grumman. So hopefully you can pick something up. And then you will see some resemblance of what we're talking here, reflect in the keynote speaker Bill just mentioned earlier. And then hopefully you can get something out of this. All right. So here, what we're going to talk about today. We're going to talk about. We will explain. We'll talk to you a little bit about Northrop Grumman, the company, and then the MDE process. How do we? What the steps we use to do the process, and the tools we use, right? And then the results, and then challenges of adapting MDE into a legacy system, and lesson learned. Just for a little bit of background, when I came here in 2011, I did the MDD top-down approach, right? But after that, I moved to a different site, and I have to use the same process with a legacy system. And this is the result of what I have learned for the last 3 years of doing that project. Okay, so Northrop Grumman is the third largest government subcontractor company, right? And then we do everything from unmanned to manned vehicle and satellites and a lot of other stuff that we don't have enough space to show here. So go on Google, you should see a lot of products and a lot of things that we have to deal with customer that we cannot present here. Okay. And here are the main 4 steps that we do. We associate with from system engineer down to software. And then I'm not sure if we main audience here from anybody here from system. Okay, so I guess we're mainly software. But we in the process, we have to talk with the customer and then get the requirements and then go down to the system. So the first step, system architecture, right? In this step, originally we would get a set of requirements, and sometimes the customer provide us DODAC products, and they give us something, but they don't quite know exactly what they want. For example, for like us, we go out and buy a car. So I want to buy a car, nice, fast, beautiful, and that's it. But that's not. We cannot translate to a concrete information that we need. So we have to work with the customer, come up with different examples, different scenarios, so we can understand the requirement easily. So we know exactly what the customer needs. Right? And then the next step we do with the CSCI architecture. After we talk to the customer, we can allocate the requirements into hardware requirement and software requirement. We use the software requirement. For this talk, we focus on the software development, so we kind of putting the hardware requirement aside for now. Okay? So we use the software requirements. We use the software requirements be the input for the next layer. It's called the CSCI architecture. So at this point, we allocate the set of a bunch of software requirements to different CSCIs, right? And then each CSCI will be responsible by
What is CSCI?
a computer software configuration item. Yeah, in government, they have different kind of reviewing, right? They like SFR, system functional requirements, right? So that one will line up with the system architecture. After this layer, we will have that review. And the customer say, okay, you understand our requirements. Let's go to the next layer. Then we go down with CSCI, right? And then at this level, we allocate the requirements to different grouping. And then each of that grouping will be responsible by one software engineer lead. And we go, at this point, system engineer and software engineer work together. They have to collaborate. They have to transfer the knowledge that they have from the customer, the scenario that they use in here, push it down to the software guys. And the software understand it, and the leads now get the requirements. Now we bring down to each of the software team, what's called CSC, Computer Software Component Architecture. And then this probably be one software lead and maybe 3 to 5 software developers that we work together. And then at this point, we start generating the software interfaces, ICDs, right? And then these are the real software interface, and no longer an abstract layer up here. The more we go down, this one is more concrete. The more we go up, the face is more abstract. And after this, they come up with the interfaces, and then they come up with a CSC architecture, and they go through the development process. And at this point, in here, we have a legacy system. We understand some of the legacy system, and then in this case, the customer will come up with a new set of requirements and build on top of a legacy system. We have to perform software analysis here to know what we have right now and the new requirements, and then we kind of top down and bottom up together. So the legacy and new stuff will get together right here. And each of the phases that you saw earlier, they evolve around this process. We accumulate the input. We try to analyze, try to understand it. We build artifacts, and then we present to our managers, the management team, because sometimes we have the product line, and then sometimes the software engineer just line up the product the way they want it, but the management have different focus. So we have to go to that level of compromise so that we understand the need of the company and the need of the customer at the same time. And after that, we go through presentation, the review I was saying earlier, SFR and CDR and PDR stuff. And so this is iterative process. There's nowhere in here that stop us from even go to code level. We can feed it back to the system engineer level if need to. There's no restriction in that process. However, we try to avoid that case as much as possible. So we try to spend a little more time up front. It's not like Agile that they try to focus on developing one product and then they try to come back. Because in the government, we don't expect to have the product coming out like next year. We have a longer period of time, so we spend more time to analysis, and then we try to just have a better understanding of the product before we actually develop it. And at each of this level, customer has the opportunity to provide input back to us, and we'll feed back to the loop again. And then in this process, mainly we use UML because the customer understands it, and the software developer understands it. We use IBM Rhapsody, and the system engineer can use SysML as well, right? But if you see the overlap between UML and SysML, it's very little set of product that UML and SysML separate, the different. But that difference is we find a different way to solve that. So that's why we just focus on UML so we can go with one language, and then so that way it'd be easier. Okay, so here, this slide involved with system engineering, right? So when we do this, we talk to the customer, we talk to different stakeholders, we talk to the user, because sometimes the customer and the user are two different people, right? For example, you have the grocery shop. The customer will be the owner of the store, but the one that actually sitting there punching the machine will be the user. We bring them into our lab. We talk to them. We say, okay, so how do you perceive of using this feature in your environment, right? And then we use this diagram. Normally, you can replace this diagram with pictures, so you can relate to the user more often. But because of again, with the copyright issue, so we just do this. So basically, we're trying to tell the story here is that we have a data source. It can be from the ground, it can be from satellites, sending the data to an aircraft in the theater. And then this aircraft do processing those data and then send the data information to weapon system, the fighters, and to the ships, right? So that is the story you're going to hear, how we drive it down from the user perspective down to the code level. Okay, and then we create the use case here. So here's the air crew, here's the pilot, here's the fighter that they're controlling the aircraft. And then we use an activity diagram to explain to them, okay, so here are the 4 steps that we're going to do in this process, right? So the goal is that we have to understand the customer needs. And then we use this artifacts to do that work. And in here, we use sequence diagram. At this point, we try to allocate the requirements to CSCIs, right? And basically, here's the structure. We use IBM Rhapsody here. Now we see that we have CSCIs. And then each CSCI will have CSC. And then we use this as a class diagram, try to give the concept of functionality of each of the CSCI, right? That one will, so after we go through this process, we have more functionality for each CSCI. And then at that point, we also do the linkage from CSCI requirement to system requirement. And then some people more comfortable with this kind of diagram, right? So we say, okay, this CSCI will have 3 components. And then how each of the component interface, for example, right here, receiving the data, and right here for transmitting the data. And sometimes the component completely inside of CSCI do not interface with the outside world, right? And then we start to migrate the customer perspective into the coder perspective. We tell how this software will be deployed in the hardware, right? So we use deployment diagram here. And for our case, right, we try to find an example of legacy system. So I went online and find this code, and assuming in this scenario that we need to find the coordinate converter, and we found this class. And then I said, okay, so this class, as example, I have this data, this sensor processor that need to do the data conversion. And then you see that in here we do modify, and then it will be modified here. So this helps the developer understand that here's a legacy code, and then here that we add this feature in here, right? So now we start pushing down to software units. And then this is the legacy code that Rhapsody has the capability of reverse engineer. So I reverse engineer the code in here. And then right here, half of this screen will be in the Rhapsody, and then this one is generated code. Basically suck in, and then I add this feature. So okay, I basically give the direction to the software developers. Okay, in this function, I will do something here. And then you see it translate to the code. I can hand this code to developer. We can put the pseudocode here, and then they have the direction how to do it. And in this case, I add a new function. And then this new function translates into the .h file. It explains the description of the function, and it explains what needs to be done for that function as well. Oh, so there you go, the highlights. So I'm going to have Billy talk about the results and our experiences.
Can you guys hear me all right? So I don't have architect anywhere in my job description. I'm just a complete software engineer, right? So I'm here to give my perspective on how this method has worked for us. So every project I've been on that has used MDE has passed PDRs and CDRs successfully with minimal RFIs, full award fee. It seems to have, I guess, given the customer a level of confidence because of all the detail that we go into and the amount of interaction that they have at each level. They also created a framework of collaboration and communication. Before the MDE process, we had this stovepipe engineering thing going on. The systems engineers and customers would get together and define system level requirements, and they'd hand it off to the requirements engineer, and the requirements engineer wouldn't have any perspective on what the customer wanted. They wouldn't be involved. So it was up to the system engineer to kind of interpret the things that the customer was saying and provide it. So the requirements engineers would take those requirements and develop CSCI and CSC level requirements and hand them to the software engineers, and the software engineers would say, well, what are you doing? I can't code this. These aren't very buildable requirements. So they would go through this big loop, and eventually they'd agree and then write the code and hand it to test, and test would say these aren't testable requirements. So they there was no interaction at all. Everybody was in their own little world. This created the MDE process created a level of communication that we could handle. Everyone can talk to the model, right? So it reduced integration issues. Legacy engineers are gone after 10, 15 years or so you lose a lot of knowledge there. Building the model helped regain a lot of that legacy knowledge, and also the implications of changing and adding interfaces became evident early on in the design. I was talking about the stovepipe design, or the stovepipe engineering we had going on. It increased testability. It increased testability a lot because our test engineers would participate in each level of the design and say, these requirements are testable. This system is testable. And if they thought there were too many things that were by, I guess, were untestable, they could change it. Also, we still gain the benefits of object-oriented design, even building on top of a legacy architecture that isn't object-oriented at all. All right, so good results didn't come without challenges, of course, right? So we had targeting tools. What kind of UML tool are you going to use? You have requirements tools like doors. You currently use source control. If you're just using the Windows file system, it'd probably be good to use clear case. You're going to want to, or something like that. All of that's going to accrue costs. You have to account for training for the tools, training for the MDE itself. Integrating existing tools and processes was also a challenge. If you already have source control or requirements management, how does that fit into the MDE? I mean, those are things you have to consider when you're considering using the MDE. So, do they work well with the other tools? So, I mean, if you are using Subversion, right? And if you're using Subversion and you bring in Rhapsody, then you're not going to get any kind of interface there, so you won't be able to use it. So this third challenge is, definitely affected by the first two. You got to gain full commitment and support from your leadership. So, how do you justify the cost of the tools? How do you justify, taking people out of the game for 2 weeks, to get them trained? You have to, sell the benefits of the MDE. You got to, explain that you're giving the customer a level of design that they didn't expect, and you'll have to explain that you are increasing teamwork and cohesion. Also explain the benefits of object-oriented design. So, and you can't just convince leadership. You have to convince everybody else that's involved as well. I can talk about the stovepipe design that we had with you know, how we did things. If your organization is something similar, you probably have engineers who live in a bubble, right? So it's hard to.
I mean, yeah, for this case, right? I have to look at this software, that we have to rehost that software, and then this, after rehosting to a new environment, it has to work nicely with the other system. And I see this folder, more than 1,300 files, C files. There's no subfolder, no component. They can't componentize into different CSC. And then it's just a big mess. And then now you add another thing on top, like Bill said earlier. All of this stuff, I'm sure that you kind of you can relate to Bill just said earlier. That if you new thing here, if you don't isolate them, now you create a bigger mess. And they're very hard to maintain, very hard to understand, very hard to fix later on. You're afraid that if you fix at one point, it might break the whole system down. So that kind of thing that we're talking about the stovepipe here, right?
Yeah, so I mean, partitioning legacy software components is also an issue too, because you have responsible engineers that have been there for 10 years that have just been doing software maintenance the whole time, right? So they'll get a couple requirements in, and then they'll make a change, and write it up and say, this is how I fix it. But now you're giving them a big change to do and expecting them to go, now talk to people and interface with everyone and do this design. They're gonna not be comfortable with that, right? So there's a couple lessons we learned, right? We got to allocate enough time for design. I mean, I wish we would have spent more time on that, analyzing algorithms and exploring alternative patterns and contactors that we didn't do. Perform our trade analysis on cost products that we had. We needed a prototype more often. If you can't do it as an architect, I mean, you have one of your developers to prototype, as often as possible.
Yeah, I mean, in the process, all of those 4 phases, at any point you can ask for the prototype effort. Have the software engineer go out prototype. If you have the timing constraint, potentially you have to do the balance between componentize and meeting the requirements. That way that you have to play around a little bit, and then you have to have the result to back up with the design decision, right? So that's where the prototype effort is needed.
And it's helpful to revisit use cases at every level. I mean, at every level, part of the design becomes more evident that it's more important. So I mean, sometimes it may be important enough to develop some use case. So also, I mean, there's other things that become less important. You don't want to eclipse, important parts of the architecture that the customer thinks are important just because it started off that way. And don't underestimate the effort of changing the existing culture. I mean, that's extremely hard to do.
Yeah, it's very hard. Right? For example, some engineers, they sit there, they clean up that CSCI for the last 20 years. Why do I want to change? I change, that means I potentially lose my position in support of the company. And it's very hard. But I think that's it for our presentation. We are open up for questions. Yes, sir.
Have you used MDE for any projects that were considered safety critical or that required certification of any kind? And
yeah, actually the stuff that we're working on need to be in the aviation world that we have to have certified, yes. But we have to collaborate with the safety engineer and the hardware and how we partition. For example, we do green hills, right? And then you have to break up the address spaces. And then that's the stuff that we have to break down to that level at the software unit. We say, okay, we have a separate address space, and this address space only deal with the security code and those kind of stuff to convince the customer, to convince the certification people that we understand the requirements and we focus on it.
Has MDE shortened the recertification or certification times, or does it not change at all?
That part, I'm still learning in that certification area, so I can't answer for that question. Yes. Yes, sir.
You were understanding that your developer is easy to understand for all software
Actually, for our experience, the customer has some experience somewhere else about UML, and they actually ask for it. And then when we start to explain the sequence diagram, and then the sequence diagram I see it as those steps, and then how to explain the parallel processing. Even though you see the sequence diagram is a one timeline, but if you be creative enough, you can explain how all parallel and execute with each other. And then so far, the customer has no issue.
Thank you very much.